and velocity. Reading guide. Key concepts. What is speed? How can you use a distance time graph to calculate average speed? What are ways velocity can change? Vocabulary. Speed. Constant speed. Instantaneous speed. Average speed. Velocity. Inquiry. How fast? When you hear the word cheetah, you might think of how fast a cheetah can run. As the fastest land animal on Earth, it can reach a speed of 30 meters per second for a short period of time. Other than how fast it runs, how might you describe the motion of a cheetah? What is speed? How fast do you walk when you are hungry and there is good food on the table? How fast do you move when you have a chore to do? Sometimes you move quickly, and sometimes you move slowly. One way you can describe how fast you move is to determine your speed. Speed is a measure of the distance an object travels per unit of time. Key concept check. What is speed? Units of speed. You can calculate speed by dividing the distance traveled by the time it takes to go that distance. The units of speed are units of distance divided by units of time. The SI unit for speed is meters per second, m/s. Other units are shown in Table 1. What units of distance and time are used in each example? Constant speed. What happens to your speed when you ride in a car? Sometimes you ride at a steady speed. If you move away from a stop sign, your speed increases. You slow down when you pull into a parking space. Think about a time that a car's speed does not change. As the car at the top of Figure 6 travels along the road, the speedometer above each position shows that the car is moving at the same speed at each location and time. Each second, the car moves 11 meters. Because it moves the same distance each second, its speed is not changing. Constant speed is the rate of change of position in which the same distance is traveled each second. The car is moving at a constant speed of 11 meters per second. Changing speed. How is the motion of the car at the bottom of Figure 6 different from the motion of the car at the top? Between 0 seconds and 2 seconds, the car at the bottom travels about 10 meters. Between 4 seconds and 6 seconds, however, the car travels more than 20 meters. Because the car travels a different distance each second, its speed is changing. If the speed of an object is not constant, you might want to know its speed at a certain moment. Instantaneous speed is speed at a specific instant in time. You can see a car's instantaneous speed on its speedometer. Reading check. How would the distance the car travels each second change if it were slowing down? Average speed. Describing an object's speed is easy if the speed is constant. But how can you describe the speed of an object when it is speeding up or slowing down? One way is to calculate its average speed. Average speed is the total distance traveled divided by the total time taken to travel that distance. You can calculate average speed using the equation below. Average speed equation. Average speed in meters per second equals total distance in meters over total time in seconds. V equals d over t. The SI unit for speed, meters per second, m/s, is used in the above equation. You could instead use other units of distance and time in the average speed equation, such as kilometers and hours. Distance time graphs. The Kentucky Derby is often described as the most exciting 2 minutes in sports. The thoroughbred horses in this race run for a distance of 2 kilometers. The speed of the horses changes many times during a race, but Figure 7 describes what a horse's motion might be if its speed did not change. The graph shows the distance a horse might travel when distance measurements are made every 20 seconds. Follow the height of the line from the left side of the graph to the right side. You can see how the distance the horse ran changed over time. Graphs like the one in Figure 7 can show how one measurement compares to another. When you study motion, 2 measurements frequently compared to each other are distance and time. The graphs that show these comparisons are called distance time graphs. Notice that the change in the distance the horse ran around the track is the same each second on the graph. This means the horse was moving with a constant speed. Constant speed is shown as a straight line on a distance time graph. Reading check. How is constant speed shown on a distance time graph? Comparing speeds on a distance time graph. You can use distance time graphs to compare the motion of 2 different objects. Figure 8 is a distance time graph that compares the motion of 2 horses that ran the Kentucky Derby. The motion of horse A is shown by the blue line. The motion of horse B is shown by the orange line. Look at the far right side of the graph. When horse A reached the finish line, horse B was only 1.5 kilometers from the starting point of the race. Recall that average speed is distance traveled divided by time. Horse A traveled a greater distance than horse B in the same amount of time. Horse A had greater average speed. Compare how steep the lines are on the graph. The measure of steepness is the slope. The steeper the line, the greater the slope. The blue line is steeper than the orange line. Steeper lines on distance time graphs indicate faster speeds. Using a distance time graph to calculate speed. You can use distance time graphs to calculate the average speed of an object. The motion of a trail horse traveling at a constant speed is shown on the graph in Figure 9. The steps needed to calculate the average speed from a distance time graph are also shown in the figure. Key concept check. How can you use a distance time graph to calculate average speed? Number 1. Choose one point on the line. The point chosen here is 120, 600. Number 2. Number 2. Choose another point on the line. The point chosen here is 60, 300. Number 3. Find the time difference of the points 120 minus 60 equals 60. Number 4. Find the distance difference of the points 600 minus 300 equals 300. Number 5. Divide the difference in distance by the difference in time. 300 meters over 60 seconds equals 5 meters per second. Distance time graph and changing speed. So far, the distance time graphs in this lesson have included straight lines. Distance time graphs have straight lines only for objects that move at a constant speed. The graph in Figure 10 for the motion of a train is different. Because the speed of the train changes instead of being constant, its motion on a distance time graph is a curved line. Slowing down. Notice how the shape of the line in Figure 10 changes. Between 0 minutes and 3 minutes, its slope decreases. The downward curve indicates that the train slowed down. Stopping. What happened between 3 minutes and 5 minutes? The line during these times is horizontal. The train's distance from the starting point remains 4 kilometers. A horizontal line on a distance time graph indicates that there is no motion. Speeding up. Between 5 minutes and 10 minutes, the slope of the line on the graph increases. The upward curve indicates that the train was speeding up. Average speed. Even when the speed of an object changes, you can calculate its average speed from a distance time graph. First, choose a starting point and an ending point. Next, determine the change in distance and the change in time between these 2 points. Finally, substitute these values into the average speed equation. The slope of the dashed line in Figure 10 represents the train's average speed between 0 minutes and 10 minutes. Reading check. What is the average speed of the train for the trip shown in Figure 10? Velocity. Often, describing just the speed of a moving object does not completely describe its motion. If you describe the motion of a bouncing ball, for example, you would also describe the direction of the ball's movement. Both speed and direction are part of motion. Velocity is the speed and the direction of a moving object. Representing velocity. In Lesson 1, an arrow represented the displacement of an object from a reference point. The velocity of an object also can be represented by an arrow, as shown in Figure 11. The length of the arrow indicates the speed. A greater speed is shown by a longer arrow. The arrow points in the direction of the object's motion. In Figure 11, both students are walking at 1.5 meters per second. Because the speeds are equal, both arrows are the same length. But the girl is walking to the left and the boy is walking to the right. The arrows point in different directions. The students have different velocities because each student has a different direction of motion. Changes in velocity. Look at the bouncing ball in Figure 12. Notice how from one position to the next, the arrows showing the velocity of the ball change direction and length. The changes in the arrows mean that the velocity is constantly changing. Velocity changes when the speed of an object changes, when the direction that the object moves changes, or when both the speed and the direction change. You will read about changes in velocity in Lesson 3. Key concept check. How can velocity change?